All right, so the coordinates for A prime are 3, negative 1. And the coordinates for B prime are 0, negative 3. Okay, do you see a pattern that happened between A and A prime and B prime? Do you see that pattern that has happened here? Okay. So there's actually a reflection rule. So when you're reflecting across the x-axis, reflect across the x-axis, then you take your coordinates x, y, and they change to x, negative y. Okay. Now this is, it's in the same sort of notation as what we did for translations, but it's a little bit different. So you'll notice my coordinates a, 3, 1, changed to 3, negative 1. If my y coordinate was a negative coordinate, then when I change it to negative, that just means opposite. So my new y coordinate would be a positive coordinate. Basically, it's just switching whether it's positive or negative. And that's what a reflection across the x-axis does. Okay, I'm going to use the same graph, but we're going to do reflection over the y-axis this time. Reflect AB over the y-axis. Okay, so this time my line of reflection is the y-axis. So I'm going to draw this dotted line right here. Okay, so I'm going to start with A, just like I did last time. And if I'm looking at the distance from A to the y-axis, it is 1, 2, 1, 2, 3. So I need to move it 3 to the left of the y-axis. So I move it 1, 2, 3. So this is my new A double prime. And I called it A double prime so that it doesn't get confused with A prime, which was the reflection over the x-axis. Okay. Now let's try to find B prime. Well, B prime is right on the y-axis. So if I were to fold my my diagram in half, B would stay on that line of reflection. So B prime is in the same spot as B, or B double prime, sorry. Okay. All right, so then let's compare our coordinates again. So A is 3, 1, and B is 0, 3. So A prime is negative 3, 1, and B prime is 0, 3. Okay. Do you see the pattern this time that's happened? It's a little harder to see because your B and your B prime are the exact same, but if you look at A and A prime, you can see the pattern that happens when you reflect over the x-axis. So I'm going to write that reflect over the y-axis. If you reflect over the y-axis, your x, y coordinate is going to become negative x, positive y. Okay, so basically all it is it's flipping whether the x is positive or negative. And of course, you can always get out grid paper or draw yourself grid paper to see what happens. You do not have to memorize these rules. They're not something that I memorized. It's just nice to have them so that you can check your answers later on. So again, if I look, 3, 1, the opposite of 3 is negative 3. 0, 3, the opposite of 0 is 0 still. Okay. So I'm going to do a try it for you really quick, and then I'm going to talk about lines of symmetry. Okay, so now I want you to reflect A over the x-axis and then also over the y-axis. So our first reflection should be over the x-axis. So pause this, take a minute, and do those two reflections. All right, you should be back. So I'm going to reflect A over the x-axis. So that means my line of reflection is the x-axis. I notice that A is 2 away from the x-axis, which means it's going to be 2 away on the other side. So this is going to be A prime. Okay. Now then, when I'm reflecting over the y-axis, again, my line of reflection is the y-axis. So I notice that A is 1 away from the y-axis, which means it needs to be 1 away on the other side. So this is A double prime. So these should be where you found your locations after you reflected over the x or the y-axis. Okay, last video.